Anybody who's away and needs a copy of the quiz? Okay. I'm going to choose to do this with technology because I think it's a little bit faster for me. So I'm going to go to this menu here most of the time for most of these questions. I'll do the first column, 1, 2, 3, 4, then I'll do the second column. This is going to be a lower value of negative infinity, an upper value of 0.98. We're on the standard normal. This you'll have to memorize. The standard normal has a standard deviation of 1 and a mean of 0. And do you guys, is the answer 0.8365? 0.836? Or 86.35% if you went as a percentage. I didn't specify. I kind of want you to flip-flop back and forth. I don't care what you round it off to. If you went 0.863, I'm good. If you went 0.86, I'm good. Is it a 5 or is it a 6? It is a 5. Now, 0.836. Oh, 0.8. Good gosh. 0.836. Geez, 0.8365. That was fairly dyslexic of me. Who knows? Maybe I am. Oh, 2. Same as number 1, except my lower value is going to be, my upper value is going to be negative 1.52. I should get an answer less than 50%. Do I? Oh, I'm hitting enter. 0.0643. Yes? Okay. Let me know if I do this wrong, because it's a little awkward to type on this virtual calculator with my pen. Dunk. Negative 0.37. 0.3557. 0.3557. Now, if you use the orange chart, Rachel, and some of you did, the first couple of digits should match. The third one might match. The fourth one probably won't. 0.87. Oh, to the right. So now I need to go. My lower value is 0.87. My upper value is positive infinity. 0.1922. My lower value is negative 2.35. Upper value is that. 0.9906. Almost everybody. 99% of the population. Oh, and in betweener. Lower value, negative 1.69. Upper value, positive 1.69. 0.90. Well, I guess this 7 would round this 9 up to a 10, which would bump the 8 up by 1. I think 0.9090, technically. Yeah. Lower was... Move this over so I can see the question. Negative 2.21. Upper is 0. 0.4864. Lower is negative 0.78. Upper is 2.19. 0.7680. Now, just remember, for this whole quiz, Emma, we were using the standard normal with the mean of 0 and the standard deviation of 1. Make sure when you're doing a word problem, you don't just always say, oh, that's a 1 and a 0. Well, no, they'll give you the mean and the standard deviation. Or, could we find the mean and the standard deviation if they gave us a list? Yeah, we know how to do that now, too, so we could actually do the whole schmear. Number 9, negative 0.75, 1.82. You know what? Once again, that's going to round up. It's going to be 0.7390. Number 10, negative 0.22. Oh, come here. Come here. Negative 0.22. 2.02. 56.54. 0.5654. And 12, negative 2.91, positive 2.91, positive 2.91. This should be fairly big, I'm guessing. Almost everybody. Yeah, 99.64. Did I skip one? Oh, did I skip number 10? Like, I put the answer for... Oh, yeah, okay. So that's 0.5654, and this is nothing. I'll come back to that in a second. 12 is 9964. Whoops. This is going to be point... .2223. Turn the page. I said drawing these helps, at least for me. My lower value is going to be negative infinity. My upper value is going to be negative 0.88, 0.1894. What about everything below that? Well, my lower value is still going to be negative infinity. My upper value is going to be positive 0.94, 82.64, 0.8264. Everything below to the left of that. So my lower value is still going to be negative infinity. My upper value is going to be negative 2.13. Wow, really small. 0.0166. Greater than, hey, Kiera, this is to the right of. This is my lower value. My upper value is going to be positive infinity. My lower value is going to be 1.37. My upper value is going to be positive infinity, 10 to the 99. 16 is at 0.0853. $17, my lowest value, because we're to the right of that number, my lower value is going to be negative 0.37. I should get an answer bigger than 50. 0.6443. And then we got a couple of in-betweeners for 18, 19, and 20. Lower value, negative 1.52. Negative 0.52. Upper value, positive 1.52. You get 87.15, yes? 0.8715. Lower value, negative 2.1. Upper value, negative 0.58. 0.2631. And last, lower value, negative 1.85. Upper value, 0.33. 0.5971. So 20 questions, 20 marks, 1 mark per question. Give yourself a score out of 20. Questions? Hang on 1 second here. Right click. If you want to get out the handout using a graphing calculator, what we're going to look at today is going backwards. Rachel, what I spent all of last class doing was saying, look, if I tell you the standard deviation and the mean and a location on the graph, you can give me the area. What I'm going to say today is, what if I know the standard deviation and the mean and the area? Can you give me the location on the curve? Can you give me the actual x value? Can you go backwards? We did it by hand already because we've looked at the orange sheet, and you can get your orange sheet out to convince yourself that we are right. But we're going to see if we can do it with technology. This one, Emma is brand new to me, so I've played with this a few times, and I'm pretty sure it works the same way on your guys', but we're going to have to kind of improvise. We left off right here, yes? At the 68, 95.4, 97 rule. This is something that's handy. So can you turn until you're here? Colleen, can you survive without this? Just fine. This is just something I have. This is a built-in error check I have. So can you all either highlight or underline the 68, 95.4, 99.7 rule? And here's what it is. Question asks, what percent of the data sits within one, what's that symbol a symbol for? Yeah, I didn't feel like writing out. So within one standard deviation, either side of the mean. So let's draw a picture. Okay. Here's our curve. In the standard normal, the mean is 0. What was the standard deviation on the standard normal curve? The z-score 1. I'll give you a hint. The z-score 1. 1. So if I'm within one standard deviation, we're saying there's positive 1, there's negative 1. We're saying what percent of the population is in here? As a statement, we're asking, what's the probability that Z is between negative and positive 1? Oh, let's get the answer. And remember, this is how I said if you're going to use your calculator, you have to show your work. I would expect you to tell me what is the lower value we're going to use here? You just want a quiz on it. Come on. Negative 1. What's the upper value? 1. What's the standard deviation? 1. What's the mean? 0 on the standard normal. Hey, what is that area? Can you find it, please, on your calculators using the stats menu? Using the norm NCD thingy, right? And Emma, this is why I'm not too fussy on the rounding, because we're going to round this one. You get 68%? In any random population, about 68%, a little bit more than 2/3, is within one standard deviation of the mean. And in social sciences, when we talk about normal, that's what we mean. You're normal if you're within one SD, one standard deviation of the mean, whether we're talking about heights, weights, IQs, hand sizes, manufacturing, whatever, number of manufacturing defects. We say, you know what? We'll classify that as normal, as acceptable, as, you know what, fairly uniform. What percent of the data sits within 2 standard deviations of the mean? Let's quickly draw a picture again. There's 0. That would be between -2 and +2. How much of the population is between -2? By the way, this line is why I always put a line through my Z's, because otherwise it looks like -2, 2, and 2. This is why I always put a line through my Z's, so you can tell the difference between a letter and a number. Or you can make your 2's really nice. Those of you that can handwrite neatly, I can't. What are you going to do for your lower value? -2, upper value, +2. What do we get? (95.4). This time I will carry that 1 decimal. Almost everybody is within 2 standard deviations of the mean. Even Jordan, for height. Rich in the other class. I think I worked it out, and he's 1.9 or something like that. But he's within the norm. Okay. Once you're past 2 standard deviations of the mean, Now you're into the holy smokes territory. If it's IQs, you're either really smart or you're educably mentally handicapped. You would notice it. So, for example, someone over here probably would learn things quicker than average. Someone over here on an IQ test probably would speak very slowly. They might even have coordination challenges. You probably would have to or recommend them for some special classes or some special needs type things. This is how we can classify people. Birth weights, because the first thing they do when you're born, Emma, after slapping you is they weigh you and they measure you. What they're really checking is, where do you fit in on here? If you're way underweight, we either know that you were born premature, or maybe the mother wasn't getting enough nourishment. Is there something going on at that family's home? Is the mother not very poor, not getting proper? We can tell an awful lot from that, and alarm flags would go up. Over on this side, ooh, maybe there's some kind of a gland or growth problem. We need to look right now and find out, is this baby growing too fast abnormally? So this is used all over the place. Hey, what percent of the data sits within 3 standard deviations of the mean? Draw a picture really quickly. What we're saying is, how much is between -3 and +3? On your calculator, make the lower value -3, the upper value +3. What percent of the population is within 3 standard deviations of the mean? In fact, we call this the 68, 95, 99.7 rule. 95.4, but even often we won't care about the 0.4. We do care about the 99.7 because that's almost everybody but 0.3% of the population. Remember near the beginning of the year when we were looking at measurement and I showed you the video on the tallest guy who ever lived, Robert Waslow, I think his name was, where he was 8'11"? He's there. Okay. Marilyn Vos Savant, the woman who has the highest IQ test ever recorded, she's over here somewhere. So if you were doing research and some of your data was suddenly that many standard deviations removed from the average, you would either, Zach, think there's a flaw in my research somewhere, I got bad data, I've discovered something new and I'm getting a Nobel Prize, or I better have a talk with the person in charge of my research to find out what the heck is going on, because something's going on. But it would certainly be a warning sign. So the 68, 95, 99.7 rule, 68% of the data will be within 1 standard deviation of the mean. 95.4% of the data will be within 2 standard deviations of the mean. 99.7% of the data will be within 3 standard deviations of the mean. Do you need to memorize that? Did I just show you how you could figure that out really quickly on your graphing calculator if I did ever ask you a question about it? Lower, upper. So do you have to memorize it, Kayla? No. Is it handy? Do you remember when we were doing the measurement lab where you guys are measuring things, and a few of you, when you gave me your data, I said, no way! See, I was very quickly figuring out how many standard deviations you were away. And no, you're not that far away. Not a chance. So, something like this. Suppose a class has a test average of 58 with a standard deviation of exactly 4. I've made up some nice numbers. What percent of the population would you expect to average between 54 and 62? Look, 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 look. Before even going to my calculator, isn't this exactly 1 standard deviation below 58, if the standard deviation is 4? And isn't it exactly 1 standard deviation above? Yeah? I'd expect about 68% of my class to be in there. You could do it, by the way, lower, upper, standard deviation, mean, and find it, but it just happens to be within 1 SD either side. What about between 50 and 66? 2 SDs either side. I would expect about that much. Now again though, Paige, do you really need to memorize that, or could you quickly calculate it in about 30 seconds? That's why I said you can survive without this. We always just throw this out there as kind of a, if you're trying to get a good number sense of stats, it's handy, because I don't carry a stats calculator around with me. Between 46 and 70? Question, Colleen? Oh, okay, sorry. Between 46 and 70, well, isn't that minus 12, 3 standard deviations, plus 12, 3 standard deviations, because it's 12 in either direction? You know what? I would expect 99.7% of my class to be there. I do use this a little bit. Do you remember the measurement test at the beginning of the year? I gave you all a rewrite. You know why? Because I glanced at my data and it was way too spread. Something was wrong with my test. That's where I kind of use it. I don't grade on the curve, but I do use it as kind of a, I screwed up. Or, those 4 kids were lazy because everybody else is right up here and doing great. Yeah, these 4 kids didn't hand in a thing. You know what? I'm not cutting them any breaks. They just got to do their homework. That's where I use it. So can you survive without the 90, the 68, 95.4, 99.7 rule? Yep. Is it handy? Yeah. Turn the page. Now to today's actual lesson. Finding an x value when we know the area. And I want to come back to this example. I typed this up, and then last night I thought I should have started simpler first. The back of this handout is completely blank. Yes? Can you go to the blank page, please? And can you write down this? Find the following. Here's example 1. If I tell you the area, can you give me the z-score? So can you copy that question out? It takes 2 seconds. Write down as you're heading on the back of the blank page, find, and then example 1, quick curve, put a 0, z equals question mark, line, and the area is 0.7438. We'll be doing 6 questions, so kind of mentally divide the back page into 6 rectangles or 6 squares or whatever. Now, how did we do this up until now? Up until now, we would have looked this up on our orange sheet, but because it was an area, we would look it up in the decimal section. So find it. Can you find 0.7438 on the orange sheet? Well, let's see. And I think the problem here is not exactly, am I right? Is there exactly 0.7438? 0.7438, 0.74, 0.7422, I know it's somewhere between 0.65 and 0.66, but it's not exactly on my chart. I know this Z value, I know that this Z value is somewhere between 0.65 and 0.66. Ah. Calculator, and hit exit until you're back to here. We're still going to go back into the distribution menu. Doink. We're still going to find the normal distribution, Adrian. Doink. But what we want to do is we want to go backwards. In math, the fancy word for backwards is inverse. Which of those 3 looks like it might stand for inverse normal? Okay. And then I think you guys, again, do you have to hit var? Okay, so variable. Okay, and then now your screen looks like this, maybe with numbers, I don't know. Yes? First thing it says is the tail that they gave you going to the left or to the right, or have it given you something in the middle? In my drawing, is this area going to the left, to the right, or is it somewhere in the middle? I think it's going off to the, so F1 is left, F2 is right, F3 is middle. We got left already. Okay? What is the area that I gave you? 0.7438. Enter. What's the mean? Oh, this is the standard normal, so the mean is 0, the standard deviation is 1, so we'll just leave those. What's the z-score that goes with that? And I think you have to go down, execute, and hit, is it calc? When you get there, does it let you calc? Or I think you can just hit the blue execute key. Did I say the z-score was somewhere between 0.65 and 0.66? Well, that's what it really is, exactly. Write that down. Z equals 0.6551. 0.6551. INV norm. Copy down example 2 and see if you can find the z-score for example 2 using INV norm. And again, you don't know how much I would have killed for this when I was in high school. Oh. You get a z-score of negative 1.8507, negative 1.851-ish? Yeah. So this one would have been almost dead on my chart. If I look on my chart, I almost have 0.0321. I got 0.0, where is it? 0.0322. Very close. I could almost have found this on my chart, but not quite. Nikki, is that okay? Now, I'm going to change the mean and the standard deviation. Instead of finding a z-score, we're going to find an actual x value. Okay? So carefully copy this one out. I'm telling you that whatever, copy it out, and then we'll talk about what all this means. Because eventually we're going to get this into an actual word problem where we have to draw the picture ourselves too. Okay? Before you start typing, Nicole, here's what this means here. I guess whatever data that we were looking at, what was the mean? What was the average? 12. What did the standard deviation end up being? 2.6. And do I want the area to the left or to the right? And do I know the area? So this is saying, look, for, let's say it's light bulbs, and they lasted 12 months on average. I want to find out if I know 63.79% of my light bulbs lasted longer than how long? Okay. We still going to the left? Yeah, we are. Area is 0.6379. Now the standard deviation is 2.6. And now the mean is 12. I guess, what does that mean? 12.9 hours. That's how light bulbs that lasted 12.9 hours or less accounted for 63.79%. 12.91. Did you remember to change your mean and your standard deviation? Look, 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 look. That's a 12 now, not a 0. And I gave you the standard deviation. So it did. Yep. Okay. Yeah. Oh, what would I want you to show for work for that? Probably if you wrote A equals instead of area. And the same as we did for the other calculator as well. I'd like to see that, that, and that. I'm not too fussy if you tell me left, right, or center, although you can. Okay. Is that okay? Okay, try finding that one. We took some data. We found that it had a mean of 340 with a standard deviation of 19.8. If that's the case, 14.37% is below what value? What's the X value that would go with that? Nice yawn there, Jacob. tempted to throw something at you. Nah, nothing. I miss you. I got Kiera and it rebounded right off of her and it hit Chelsea right in the face. And I missed you too because they both jumped. It was like a little chunk. Ah, missed. Nicole, I've given up on. I got her good last class though. What do we get for our X value? By the way, I already know part of the answer. Joel, since it's to the left, it's got to be less than 340. Yes, yes, yes? Okay. If you get an answer bigger than 340, you probably got the thing pointing in the wrong direction. You're probably going to the right instead of the left or something. What'd you get? 0.9 what? 394? Okay. Okay. Which way are we going with this particular area now? Okay, copy it down first of all. It's a Z score, so the mean is 0 and the standard deviation is 1. And see if you know that the area to the right is 0.8717. And this I haven't tried yet, so I gotta try this. They've only added this feature recently, this left-right thing. So I want to go to the right. 0.8717. Standard deviation of 1. Mean is 0. It should be negative because I'm to the left of 0. I think that looks right. You get a Z score of negative 1.134. Last one. And then we'll go back one page and try the word problem. Let's see. I would go to the right. The area is 0.2626. Standard deviation is 1.4. I'm covering it up with my calculator, but I think that's what I wrote up there. And the mean was 14, and I guess 14.889. Let's actually use this now. Can you turn back one page and look at the example that I gave you on the previous page? Okay. Going backwards using the inverse normal, finding an X value when we know the area to the left or to the right. Suppose a headphone company knows that the average headphone lasts for 320 hours with a standard deviation of 10.5. Okay. The company is willing to offer a warranty on the headphones whose lifespan is in the lowest 4%. The crappiest 4%, we can afford to replace those. How many hours should we offer our warranty to the nearest hour? What we're really saying is this. Draw a little picture. What's the mean of this particular value, Colleen? Now, I didn't say the word mean. I used a synonym. Can you find it? Begins with the letter A. I said, instead of mean, I said average, right? Right? You get 320. Good, 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 good. And what we want to find, Colleen, is how many hours are the lowest 4%. That's what we'll put as our warranty on our box. Does that make sense, Zach? And hopefully you're saying, oh, this would actually be kind of useful for a company to be able to do. Yeah. Well, you know what? 4%, I kind of said that's barely anything. If it had said 48%, I'd probably put it close to here. If it was more than 50, I'd put it over on this side because I know that I'm not too fussy. And also part of it is determined by how close the numbers are. Will I have room to write? Which is just because I want to do a neat diagram. Is that okay? Your X should be to the left here somewhere, and it should be fairly far to the left, I think, if we're trying to go to scale. to use your graphing calculator. So Adrian, if you forget, there's the instructions. But I'm going to go like this. Exit. My tail is to the left. The area, now 4%, what's that as a decimal? 0.04. Standard deviation was 10.5. The mean was 320. All right. What's our warranty? How many to the nearest hour? Now, I got to be careful. Although if I was rounding, do you get this number? Yeah. If I was rounding off, I'd round to 302. Do you think the company would ever round up on its warranty? See, if I round to 302, I'm going to end up replacing slightly more than 4%, and I can't afford to do that. So even though as a number I would say 302, as a company I would say, you know what, I'm going to go 301 hours. In fact, probably, you know what the company would really do? They'd say 300 hours, because that's a nice round number and easy to keep track of. But we're going to write 302, because we're going to round off mathematically, not economically. But economically, I think a company would round down always. You want a warranty less, not more. And in terms of showing work, I'd probably need to see that, that, and that. And if you want to write whether you went left or right, just because in case you forget, go ahead. Abbreviation for area, capital A, sure. Everything else is pretty, oh, abbreviation for tail, I guess you could do a T. Oh, what would be a good abbreviation for left? L. How about for right? Okay. How, oh, you cross out the word batteries and make it headphones. You can see I was cutting and pasting questions here. How long will the top 2% of the batteries, sorry, headphones, last? Oh, let's quickly draw a little picture. The mean was 320. The top 2%, Kayla, I think would be way over here somewhere, and this area here is the top 2%. By the way, are you guys starting to see why I've said to you, drawing this picture, it takes 1 second, but it really makes things clearer, yes? Because now you're like, oh, to the right or to the left? To the right! Right? Right! No. Left, no, right! Yeah. Good, find it. Find the x value when you have a mean of 320, a 2% area to the right, and a standard deviation of whatever I said it was. Oh, I got that all in here, actually. I want to go to the right, to the right, to the right. The area is 0.02. The top 2% of the headphones will last for 341.6 hours. Problems with this? Well, if you said, what percent of the headphones will last for 1,000,000 hours, your calculator will give you an answer, even though it's stupid. No headphones ever last that long. It'd be a very, very small percentage. This is where this is a mathematical model of real life that doesn't always, when you get to the outliers, work quite so nice. But in the middle, it's pretty good. Can you open your books, please, your workbooks, please, to page 243. 243, sort of. Yes. Pardon me? Can you wait for 5? Okay. 5 or 10 and I'm done. So can you open your book? Yep. Is it someone in this class that has the TI calculator? Or is it my other block? Page 243. Is that what I said? Okay. 243, under the B, 2, under the I, 4. Counting. Really? Really? Well, great. Never mind. Nobody here has a TI. These instructions here are if you have a TI calculator. I've given you a handout for the Casios, so we can skip page 243, we can skip page 244, but if you're wondering what that is, it's for a different calculator, so when you're studying, don't freak out if you go, what the heck is normal CDF? It's a different syntax. What we can do is example 1. Do it. Now, bit of a problem here. Can you all look up for 1 second? What's the mean average? 3 what? What's the standard deviation? 5 what? Which is what? 3. Yes, we got to have our units matched. So let's do that. 21 days. It's going to be a 21 here. I don't think I'll be tricky like that on your test, but I'm okay if they do that in the homework. It keeps you on your toes. Lower. Math error. So double check the most common one, Nicole, look up. Maybe instead of a negative, did you hit the subtraction sign? Because then it doesn't know that is a difference. And it's thinking, oh, you want me to subtract something? Are we, folks? What are they asking you to find in this question? An area? This is why I said draw a picture. I think they told you the score, and they're saying find the area. So this is not in the same menu. This is going to be normal NCD, finding an area. Lower, upper, mean, standard deviation. Right? And I didn't tell you on purpose, because part of one of the skills you need to learn is to interpret which one you're using for which question. If they tell you the percent or the area, use in the norm. If they want the percent or the area, use the NCD. And you get 0.1151. Yeah? 0.1151. That's the probability that a package will take less than 15 days. So, they guarantee that a package will arrive in less than 35 days or the delivery is free. Right? Oh, did they say less than? Yes? You see how I'm ripping the question apart phrase by phrase? Sorry? Oh, Kayla, what? Ask it again? Which ones will be free? The ones that get there sooner or the ones that get there later? I need to read this question really, really carefully. Actually, we want that area, because those packages took too long to get there. What percent of the packages will that be? And then once I know what percent that is, I think if I multiply by the number of packages total, that should tell me how many packages I'm going to be having to ship for free. Yeah? Good, go. Lower, upper. What was the 5? Do you guys get a answer like that? Scientific notation. Hang on a second. See if I can fix this. Second function set. We might be stuck with that. Hang on. Norm. Nope. Okay. You get 2.5551 negative 3. Emma, you want to give him an elbow for me? You get that? Yeah? Okay. Here's what this means. That little negative 3 there tells you put a decimal. This is scientific notation. Those that are in physics or chem probably have seen this, but put a decimal. This is 2.55 times 10 to the negative 3 in scientific notation. So it's going to be 0.1, 2, 3 is the first 2. It's that. So, sorry, what? The number of packages is going to be 0.002555 times 8,257. How many packages? Yeah. Hustle back and hustle back. Ed, hustle back. Sorry, I thought it'd be done by this time. It's been a lot of talking. What do we get? 21? Anybody else? Yes, yes, yes. They can expect to ship 21 packages a month for free. Sorry that you get a scientific notation-y answer there. It's going to happen sometimes for small numbers, and if you're not sure, I'll help you translate it. Skip example 2. Page 246. Here's that going backwards with the inverse norm. Okay. And we are done. What's your homework? Now, I'm going to press pause. On Monday, I'm not going to be doing a brand new lesson. I'm going to have a big practice sheet of questions for you to try. But for now, number 1, number 2, number 3, Four is good. Five is good. Smallest, what minimum height? 6 is good. Mr. Dueck, yeah, they go fast and you need to practice. I want you to get practice with the wording. Yeah, 7 is good. So far I've assigned everything I know, but we'll talk about a lot of these on Monday. Skip 8. Woo! Standard deviation of 5, 50% or taller than... Sure, I'll stop there.
No.